in today's lesson, I'm specifically gonna focus on the 7 calculations. And I promise you, grade 12s, it's not difficult. It's simple calculations with simple formulas. So if you want to go and revise Mapwork, always go and look at the formulas. Okay, now let's get started. If we look at our map that's presented on our screen to us, before I'm going to continue, I'm just going to point out, before I look at the calculations, I want you to pay attention. So the map we're dealing over here is the topographical map. Okay. Now, you will know, once you do the Mapwork paper, you get 2 sets of information. One is the topographical map, and one is the orthophoto. I'll get to the orthophoto in a while. So let's just focus on the topographical map. Okay. Now, if you look at the topographical map, very importantly, we've got a scale. Now, the reason why we have a scale is because the map is being reduced, or else we won't be able to fit it on a piece of paper. Okay. A topographical map has been reduced 50,000 times. Okay, so it means 1 centimeter represents 50,000 centimeters, very importantly. So when we calculate distances, the reason why we have a scale is to be able to determine distance. And what do we use in distance? We use kilometers and we use meters. Okay, but let's look at another key areas. Now, the map, the extract we're looking at Worcester. It's in the Western Cape province, and then there's sets of information over there, 3319 CB, and I'll explain that to you in a bit. Furthermore, we look at latitude and longitude. Okay, that's the first 3 topics I'm going to discuss with you. Okay, the first time you were introduced to coordinates was back in grade 9. Okay, and I still see that grade 12s are struggling with coordinates. Yes, I know the majority of the stuff that you learn in school, you're not going to use after school. But believe me, you're going to use coordinates. If you want to find yourself on your way to a wedding, or you need to go and find a farm, or you need to go and find a venue to go and see a concert or rugby match or whatever, you type in the coordinates into your phone and you will get to exact location. Okay, but let's continue. So I've mentioned to you the scale is 1 to 50,000. So it means it's been reduced 50,000 times. Okay. And then we look at the map code that was introduced over there, Worcester 3319 CB. That's map code. So I'm just going to write there, Worcester 3319, just want to correct, CB. Now what does this actually mean? Okay. Let's decipher it because it's map code. The 33 represents latitude. The 19 represents longitude. Okay. C represents big block on your grid reference. And B represents small block. Okay. So immediately when we look at this code being presented on the map, we're dealing with coordinates. Okay. Now when we deal with coordinates, we're dealing with lines of latitude and we're dealing with lines of longitude. Now let me quickly explain it to you. Now let's assume we have a map. Okay. Let's assume this is a world map. Now first of all, you need to know, and if I can draw South Africa like that on the world map, and this is Africa. Okay. First of all, what separates the northern hemisphere from the southern hemisphere? It's known as the equator. Okay. What separates the eastern hemisphere from the western hemisphere? The Greenwich. Okay. Now, very importantly over here, grade 12s, you need to know, when we look at latitudinal position, it's the horizontal lines. Okay. Where do we find South Africa of the equator? South of the equator. So our latitudinal position will always be south. Now, if we look at our longitudinal position, where do we find ourselves of the Greenwich? There's north, there's east, there's south, there's west, even a little bit more to that side. We find ourselves east. Okay. So immediately when we need to go and determine latitude and longitude, South Africa finds our latitudinal position is south of the equator and our longitudinal position is east of the Greenwich. Now, just another example. Remember, when we work with coordinates, we deal with degrees, minutes, and seconds. Okay, so I want you to imagine, think of the degrees as hours, because we're already dealing with minutes and seconds. Okay, now if we're dealing with 60 minutes, very importantly, this is a key formula that you can always use. 60 minutes equals 1 degree. And it sets in confusion, especially when we move over that 60 minutes. So I'm just going to draw you a virtual map. Okay, these lines represent latitude. We discussed that. Okay. The vertical lines represents longitude. Now, we're just drawing a virtual map, our own map. Let's assume this latitude line is 28 degrees, 58 minutes. So our next latitude line will be 59 minutes. Okay. What will happen after 59 minutes? It will turn to 60 minutes, but we don't refer to it as 60 minutes. We refer to it, it moves over to a new degree. So it's going to be 29 degrees, 0 minutes. There's 1 minute, and there's 2 minutes. Okay, please pay attention what happened over there. As you can see, we went from 58 minutes to 59 minutes. We don't say 60 minutes. When you look at your watch, you don't refer to when we moved over to the next hour as 60 minutes, 12 hours and 60 minutes. No, what happens? We move over to 1 o'clock. Okay, vitally important. Remember, we're working with degrees, we're working with minutes, and we're working with seconds. And obviously the direction will follow. And what's the direction for latitude? Always down south, because we are south of the equator. Okay. So we've just done our latitude. Let's just quickly do our longitude. So let's say our longitude is 19 degrees, 15 minutes. So our next longitude is going to be 16 minutes, 17 minutes, 18 minutes. Okay, so we just did a virtual map. Now let's assume I ask you to provide me with the coordinates of the school in the grid over there. I'm going to do 2 examples. And now, where do I get this key from? Now, you will notice, I'm sure all of you know, when you're writing your exams, on your map, on the bottom of the map, you get references, keys that represents information. We're talking perennial rivers, we're talking infrastructure, such as roads, railway, etc. Okay, so this is where I get it from. So an S with a little dot represents a school. Let's use another one. Okay, to indicate height on a map, we use trig beacons. So a trig beacon is a triangle. Let's make it number 9, and the height is 100. So I'm going to ask you to provide me with the coordinates for the school. Now remember, grade 12s, when we read coordinates, where do we start? We start with our latitudinal position. And what is South Africa's latitudinal position? Always south. So moving down there towards the equator. Okay, from the equator. Apologies. Okay, if you look back at this map, where's our latitude going? It's going down south. Okay, our longitude is going east. So we start with our latitudinal position. So let's say I ask you to provide me with the coordinates for the school. Now what do? You start reading your latitudinal position. 28 degrees, 58 minutes. It's not in that grid. It's also not at 59 minutes. 29 degrees, 0 minutes. So we do find the school between 29 degrees, 0 minutes, and 1 minute. Am I correct? So we can start writing our latitudinal position. 29 degrees and 0 minutes. Okay. Now, grade 12s, what did we find between minutes? Seconds. Am I correct? How many seconds is there in 1 minute? 60. Am I correct? Now, if we take our virtual map and we take this grid, I'm just going to do it on this grid over here, and we divide it into a half. If that's 0 minutes and that's 1 minute, how many seconds do you think that line represents? 30 seconds, am I correct? If I take our first half and we divide it up in half, how many seconds will that represent? 15 seconds. If I take our last half and we divide it up right in the middle, it will represent 45 seconds. Now, grade 12s, we don't expect you to get the correct seconds every single time spot on. So because if you look at the grid, to go and draw 60 lines in between that grid is going to be very time consuming. So what you can do is you can almost just round it off to the closest seconds that margin that you can get. So in this case, if that's 45 seconds, right? Am I right by saying we can say that the school is probably going to be at 55 seconds? Okay, 55 seconds. And what's the direction we move in with the latitude? South. So we provided half of the coordinates now. Okay, now let's go and have a look at the longitudinal position. Now, same procedure. 19 degrees, 15 minutes. 16 minutes. So we do know that the school is situated, have a look here, between 16 and 17 minutes. So we can start writing the coordinates down. 19 degrees, 16 minutes. Because it's between 16 minutes and 17. Okay. Now, once again, exactly what I've done with the latitude, I'm going to practice with the longitude. If I take my grid and divide it up in half, between 16 minutes and 17 minutes, how many seconds do we find ourselves in? There's 60 seconds between them. If I take that grid and divide it up in half, how many seconds is that going to be? 30. So we can write down there 30. We take that last section and we divide it up in half and we get roughly 45 seconds. So where will we find the school? As you can see, almost at 45 seconds. And what's the direction we moved into? We moved in an easterly direction. So our coordinates for the school will be 29 degrees, 0 minutes, 55 seconds south. 19 degrees, 16 minutes, 45 seconds east. Okay, let's just do another one to make 100% sure, because keep in mind, even though you may not have to actually go and write the coordinates down, they might ask you to go and find the windmill or the excavation on the map at the following coordinates. So the examiner might provide you with the coordinates where you need to go and find a specific area or place on your topographical map. So it's vitally important that you know how to read your coordinates. But let's just do another one for the sake of it. Okay, so that was our first one. Now let's look at our second one. Provide the coordinates for Trick Station 9. I will explain to you now in a bit what a trick station is. Okay, so once again, we start reading our latitudinal position. 28 degrees, 58 minutes. 59 minutes. So 59 turns to 0 minutes, but what happens with the degrees? It increases. So it's 29 degrees, 0 minutes, 1 minute. So we find the trick station between 1 minute and 2 minutes. So we can start writing 2 minutes. 29 degrees, 1 minute. Okay, once again, we divide our group in half. We get 30 seconds. Divide it up, the last quarter, roughly 45 seconds. And which direction did we move? We moved down south. So we've got a latitudinal position. Okay. Now, if we look at our longitude position, 19 degrees, 15 minutes, 16 minutes. If we look, we find the trig station between 15 and 16 minutes. So it's 19 degrees, 15 minutes. Okay. Now, once again, we divide our grid into half. Divide our first quarter into half, and I'm guessing we will find the trig station at 10 seconds east. Okay, so our coordinates for the trig station will be 29 degrees, 1 minute, 45 seconds south, 19 degrees, 15 minutes, 10 seconds east. Now, that's coordinates. To be able to understand the map code, you need to understand coordinates. Now, if we go back to our map, as we can see, Worcester is found at 33 degrees 19 CB. The 33 means latitude, 19 means longitude, C means big block, B means small block. Now, to go and draw it for you in perspective, this is what they meant by it. Okay. 33, 19, just want to make 100% sure, it's CB. Okay. So, if I can go and draw the map code for you, the map reference, it's 33 degrees, 19 degrees latitude, so obviously what will be the next will be 34 degrees. This will be 20 degrees. Remember, the 33 represents latitude, the 19 represents longitude. Okay, now C means big block and B means small block. So what do? We take our grid and we divide it into 4 blocks, A, B, C, and D. Okay, so what did we identified the following. We know we found the town of Worcester at 30 degree latitude, 19 degree longitude, and big block C. So we know it's situated in big block C. So what do we do now? We take our big block C and we divide it into 4 small blocks, A, B, C, D. So where do we find Worcester? 33 degrees, 19 CB, big block C, small block B. Okay, so that's the map reference for Worcester. But now how are they going to ask this question in the exam, in your prelims exams, final exams? Very simple. The question might state, provide the map code east of Worcester. Okay, now I like this question because what they've done now, they integrated your direction with it. You need to know your 16 cardinal points. You've done it since, I think, primary school. Okay, what's your 16 cardinal points? Let's just quickly have a look at it. Okay, it's basically your compass. You've got north, east, south, and west. Northeast, southeast, southwest, northwest. Remember, that's only 1, 2, 3, 4, 5, 6, 7, 8 cardinal points. We still need to add a little bit more. Okay. In between, we have north, northeast, east, northeast, east, southeast, south, southeast, south, southwest, west, southwest, west, northwest, and north, northwest. Okay, that you should know. So what we've done over here, we have integrated direction into your map code. So let's just assume the examiner asks you the following question. Provide the map code east of Worcester. Okay, now, east of Worcester. So what do we need to do? If Worcester is situated at 33 degrees latitude, 19 degrees longitude, big block C, small block B, what will be directly east of small block B? Now remember, if I can draw my 16 cardinal points over there, there's north, there's east, there's south, there's west. Okay, so what will be the map code directly east of Worcester? It will still be 33 degrees, 19 longitude, big block D, small block A. Okay, so that will be the map code directly east of Worcester. So I just want to do another one. So sometimes it might happen that we change in coordinates. It means we might change the longitude, we might change it in latitude. So I'm going to use a simple one. I'm going to use example as Johannesburg. Let's assume Johannesburg has a map code of 24 degrees, 30 minutes, DD. Okay. And the examiner asks you, provide the map code south of Johannesburg. So the question asks, provide the map code south of Johannesburg. Okay. Now the safest way to do this, grade 12s, is to go and construct your grid. Okay. Easiest way, because confusion might set in. Okay. So let's have a look at it. 24, and we're revising over here. What does the 24 means? It means lines of latitude. 30 means lines of longitude. So obviously, what's that going to be? That's going to be 25. That's going to be 31. Okay. The first D represents big block because we take our grid and we divide it up into 4 blocks. A, B, C, D. And the second D represents small block. A, B, C, D. So we know Johannesburg is situated at 24 degrees, 30 degrees, 24 degrees latitude, 30 degrees longitude, big block D, small block D. Now the question was asked, provide the map code south of Johannesburg. So what's going to happen? If that is where Johannesburg is, there's north, east, south, west, the direction of it. Okay, so what's happening over here? Look what happened. We're extending down to a new longitude. So, what will we find south of Johannesburg? 25 degrees. It will still remain 30 degrees longitude. Okay, which block will it be? There's block A, there's block B, block C, and block D. Do you agree with me? It will be in big block B and small block B. We take our grid and we divide it into 4 small blocks. So the map code south of Johannesburg will be 25 degrees, 30 degrees longitude, big block B, small block B. Okay, that's the map code. Okay, so obviously to be able to understand and do the map work, you need to know your coordinates quite well. Okay, so we've just done direction as well. A simple example of direction while we at it, when they ask you in the map, provide the direction from, let's say, spot height 100 to, let's say, the wind pump. Okay, always remember, follow the following steps. First step, draw a north-south line. Second step, draw a line from, where, and to. Okay, in this case, if the examiner asks you to provide the direction from spot height 100 to the windmill down there, first step, go and draw a north-south line. Unfortunately, my hand is not steady to draw a perfectly straight line, and you go and draw a line from where and to. Now, once again, if you look at your direction, there's north at 90-degree angles. You will find east, there's south, there's west. Do you agree with me? From spot height 100 to the windmill, the direction will be southeast. Okay, quite simple. But once again, matrix, you need to know your 16 cardinal points. Vitally important.